Gustavo wanted to increase traffic to his website by buying ads on other websites. 1 month after buying his first ad, he had 4,200 visits to his website. 3 months after buying his first ad, he had 6,048 visits to his website. If the traffic to his website increases by a constant proportion every month, write a geometric sequence to represent this increase. Now, if you're looking at that guy right there, you should be thinking, all right, well, I'm allowed to use a calculator. That guy looks an awful lot like this because they basically are the same. This is exponential regression. So what we're going to do is we are going to run to our calculators and we're going to use exponential regression to write an equation. And then once we have that equation written out, we'll just fix those letters and stuff like that. All right, so Gustavo wants to make a geometric sequence, which is the same as exponential regression. So what I'm going to do is I'm going to go to Stat, I'm going to go to Edit, and I'm going to type in my 2 data points. 1 month matches up with 4,200. Okay, bada bing. Month 3 is 6,048. Like so. Now, all I care about is the equation, so I'm just going to quit out of this. I'm going to go to Stat. And again, you're not looking for geometric sequences. Geometric sequences and exponential regression are the same exact thing. So if I hit exponential regression, go down to Calculate, it gives me y equals 3,500 times 1.2 to the x, which, not using the exact letters, matches up with B. All right, so the equation that we came up with is y equals 3,500 times 1.2 to the x. So all we really have to do is, replace y with g of n and n with x. And we're not going to get that one, but we're actually going to get that one, which is B. I don't know why I circled the stuff in A. I just wanted to show that, g of n and regular n. But B is going to be our guy.